Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 68. And today I'm joined by Steve Smith, also known as Ardalis on the socials. So welcome to the show, Steve.
Hi, thanks for having me.
You're welcome. Now I've got a feeling that you probably need no introductions because you're quite well known in our community. But for those that haven't heard of you, could you give the listeners a quick intro into yourself and what you do?
Sure. My name is Steve Smith. That turns out to be a super common name, so I've been going by Ardalis online for a couple decades now, because usually I can get that username. And I work for Nimble Pros, which is a company my wife and I run, and we have a small consultancy where we help teams build better software faster. And one of my passions for the last, 20 years has been mentoring and training developers on how to write code that's more maintainable and higher quality. And so things like design patterns, domain-driven design, clean architecture, testability, all that stuff are near and dear to my heart and things that I enjoy sharing with others.
I know what you mean about names because Dan Clark is also a very popular name. So that's just, I couldn't believe I managed to get the domain name danclark.com. This was a long time ago. I grabbed it and then I got contacted by someone that was a racing car driver called Dan Clark who wanted it. So I said, you can have it for X thousands of pounds or whatever. Right. And they quickly said, no, that's all right. And I could see they've got something else now. So yeah. I've kept that all along.
There was a time when I was in the first page of Google results for Steve Smith, but that time has long since passed.
So before we jump into Modular Monoliths, just a quick reminder to everyone that this podcast does have a Discord community. If you head over to the website, unhandledexceptionpodcast.com, there's a big Discord link there. And also a thank you to Everstack for sponsoring the podcast. Everstack's my own company providing software development and consultation services. For more information, visit everstack.com. And speaking of sponsors, the show is currently looking for additional sponsors. If you're interested, the details are on the website. Right, so Modular Monoliths. So a small confession, I really wanted to watch all of your course before we did this recording, and I got about 50% of the way through, but time, you know what it's like. Yeah. But so I've seen half of it, but it might actually be a good thing that I've not listened to the full course because I guess it means my questions aren't seeded by like knowing questions, and it can be a bit more of an organic conversation. So this podcast is a .NET podcast, and your course is, it's Modular Monoliths, but it is for .NET. So to help listeners visualize this a bit better, can we first start off with just talking about, from a code point of view, from .NET, what a module is in terms of this .NET stuff? Because I think when I've looked at this initially, I've heard lots of abstract stuff, but I wanted to visualize this as a .NET developer. So is a module, is that literally just a .NET project, like an assembly?
It can be, and that's mostly the approach that I take in this course. There's a few related classes, and there's some reasons for that. The thing about C# is that it doesn't support friend assemblies, and so there's no way for you to expose part of your project to another project or to certain other projects in order to allow for modularity, but also allow for encapsulation. And I'm a big fan of, if you're doing object-oriented programming, of using encapsulation so that you can enforce invariants and have a contract that you maintain with your collaborators, with your clients, then allows you to kind of change the inner workings of your class however you want. But more importantly, to make sure that other things can't go in and just fiddle with the data inside of your class. And that's really one of the real big reasons why people ought to be thinking about building more modular systems, whether monoliths or microservices, is because if you just have a typical application with one database and maybe many applications all sharing a database, that's more common, at least in the enterprise, you have no control over who can touch any of your data. Yeah, because any application that has access to that database can insert or update records anytime they want, and that makes it really difficult for you to make any kind of guarantee about the state of your system.
I've worked, and I'm sure we all have, with lots of legacy code bases where over time lots of developers have touched it and different design patterns have used. And as you're saying, different things are talking to different parts of the system, different databases, or the same database even, and treading on each other's toes. And just when you look at almost like a kind of end depends diagram, right? And you've got spaghetti lines of code everywhere and stuff. It does feel like, I guess, if you were starting from scratch and not doing microservices, would you ever build a monolith that isn't modular? Is this mainly about improving legacy balls of mud monolith where it's got to this state?
Yeah, I don't know that I would necessarily start with a modular monolith every time. It would depend on what I expected the scope of the application to be. So this would be, an architectural decision. You could just build and most applications should just be built as simply as possible with a single project and get some stuff working and get some fast feedback from stakeholders. But as it continues to grow, it's going to slow down because of the fact that it's going to get more and more complicated, and every new feature you add has to interact with all the existing features. And it's at that point that you need to start having some more discipline and some more thought into how can I make sure that when I do add additional features, I'm not breaking the things that are already there. And that's what tends to slow companies down and code bases down, is where you used to be able to get a feature done in a day, and now it's like maybe we can get a feature done in a month, but we're also going to have to spend 2 weeks fixing bugs everywhere every time we try and do that because everything is a tightly coupled big ball of mud.
Yes, I know that one well. It starts off so fast with the Greenfield project development and knocking features out left, right, and center. Then over time, it becomes, just like wading through a big ball of mud, really, I guess.
Right.
A very good term. You mentioned about databases before. So, like, obviously, when doing microservices, it tends to be recommended where, like, each service or what's the DDD term?
Each bounded context.
Bounded context, that's what I was after. So each bounded context has its own database and things. And with modular monoliths, is it the same concept that each module would have its own database?
Yes. You can think of each module in a modular monolith as being equivalent to a microservice. And in terms of all the rules that you would apply to a microservice, typically in terms of design, like the fact that they should be independent from one another, they should be able to be deployed independently, they shouldn't share global state through a database or some other mechanism. All those rules apply to modules in this modular system. That's what makes them modular. If they did have tight coupling to other modules, then they wouldn't be modular, right? Imagine if you had Lego bricks, but you glued them together. Like, you no longer have two Lego bricks, right? You have one bigger Lego brick. So that's important to keeping that separation for this to work.
Yeah, it definitely does feel like way more productive doing it this way, because I know I've worked with a couple of systems that are more, quotes, microservice kind of architectures, and like where if it's all in one solution, one solution, it can be pretty much a function call, which is super easy. You can debug into it, you can do all this stuff. Where when it's always HTTP or gRPC calls, and you've got to manage the actual DTOs and like if you debug it, you can't just step into it and that kind of thing. It feels way more productive. It feels like there's so many pros and cons to using microservices versus like a modular monolith. It feels quite hard for a team to decide. Have you got some good questions that a team should ask themselves, or is this kind of just a modular monolith is a good stepping stone to actually start with that, and then if you need to go to microservices, you can then break it down further?
Yeah, there's a diagram that a lot of people have used, and I use it in my modular monolith course. And think of it with two axes, right? So horizontally on the x-axis, there is the number of things you deploy for your application, the number of independent services, let's say, right? And so on the left, you've got one, which would be a monolith, and on the right, you've got many, right? However many. And so microservices would be, in the right column, let's say. But now vertically, we've got two options as well. We've got zero modularity, where everything can touch anything else, and we haven't put in place any kind of boundaries, like, when we talk about a bounded context, it has boundaries around it. And so if you have no boundaries, if you have no modularity, then you're at the bottom of the vertical axis. And if you have modularity, if you have boundaries, then you're higher up, right? And so every application starts in the bottom left, right? You do file new project and it says hello world. You have no modularity. You just have one project. You have one deployable, and that's where you stay. And you may stay there for a long time, right? Many years. You might build a huge system there. But if you get a really large, complex system, then it does tend to turn into a big ball of mud because it doesn't have that modularity. And so many developers, especially in the last 10 or 15 years, have seen that to be a problem. And the industry has told them the solution, the salvation, is to go to microservices, because that is the only way that you could decouple all your logic and have them be, bounded And in this case, the way we're going to make them separate is because we're going to put a network between these two things. So the only way they can talk to each other is over, some out of process communication channel. And so you're moving diagonally, right? You're moving to the right by deploying more services, and you're moving vertically because you're achieving modularity. And it turns out that that's a really big step. That's a really big learning curve for a lot of teams, because understanding, architecting, building, and maintaining a distributed architecture like that is leaps and bounds more difficult than a monolith. And so, yes, my proposal for many teams would be, unless you have a really good reason to go to a microservice architecture, it makes more sense to only move across one axis, move up, and add modularity to your monolithic application so that now everything is still in one process. You can still build it and run it and debug it in one solution. And when you deploy it, it's one thing. But you still have all the benefits of modularity, which means that you can develop these different modules with separate teams if you want, right? A lot of folks use microservices as a way to scale up the number of developers they can throw at the problem. Well, you can do that with modules in a monolith just as easily as you can with microservices. And all the other benefits you get from that modularity without having to deal with all the fallacies of distributed computing that come along with microservices.
Makes total sense. And I guess, presumably you can do a hybrid as well. So if you've got like one module that really has to be scaled out separately for whatever reason, then you can keep the whole system as a modular monolith, but just pull that one thing out because you've broken everything down nicely in the first place into these modules.
Yeah, exactly. Martin Fowler has a nice article from, 10 years ago talking about how to go to microservices. And basically the article says, build a monolith first, right? That if you try and just build microservices up front, here there be dragons. And he's got a nice little picture with dragons on it. So, the better thing is to build that monolith, understand the system, build it in a modular fashion. And then when you say like, oh, the video transcoder thing needs to scale independently from everything else, and it's its own module, right? We'll just take that module and put it into a microservice, and great. Everything else is still as efficient as it possibly can be in terms of developer productivity and performance, because when everything's in process, performance is much better. Your hosting costs are lower when everything is deployed in a single thing. But those individual things that make sense as microservices could certainly still be pulled out. Exactly.
How does this work with like front ends? So, like, as I say, I'm halfway through your course, so I saw that you were using APIs as an example. And as an aside, it was quite nice to actually see fast endpoints in action, because we've had, when was it? I don't know what episode it was, but Nick Chapsas has been on a couple of times. The first time he mentioned this, and do you know how every developer's got a long list of things they want to play with, but
right.
it's always a long list and it gets bigger. It's been on my list for quite a while, so it was quite good to see that in action. But anyway, I kind of diverged from what I was initially saying then. Yeah, so is it okay to have like your entire backend being kind of a modular monolith, but then multiple front ends if you've got different applications that need to use that logic?
You could have, if you're building a bunch of APIs like in my course, you could certainly have multiple different clients of that. If you're building a single application, then you can still use a modular monolith approach for the back end. And then depending on what your technology is for your UI, there's various different ways to be more modular in your UI, right? So if you're using Angular or React, they each have different ways of using components and routes and things like that, so that you could have different sections of the app that correspond to, this is the order processing section and this is the reports section or what have you. And so you can build modular user interfaces just like you can build modular backends. And if you are sticking strictly to .NET, Blazor has support for this with Blazor, Razor libraries. And if you're even just using MVC, you can use areas, you can use Razor pages, you can use controllers and views, and those could live in separate projects, but all still get pulled together at runtime and hosted as a single monolithic ASP.NET Core application, even though all their pieces, all the UI components, would live in separate modules and perhaps be owned by separate teams.
We've spoken about scalability, and to be honest, I very rarely see an issue where I need to scale out one particular thing, because I'm not building Twitter or X now or Stack Overflow or anything. Even like Stack Overflow, I think that they did a post a few years ago that they showed them running everything literally on one server.
Right.
So it's kind of, if with their load, if they don't have to, then nothing the average developer is building probably has to as well, very, very often anyway. But one thing I do like about microservices is the independent deployability side, where if there's quite a few developers working in different teams on a system, and say I need to make a change to, an email service, for example, just off the top of my head, then I can quickly make that change and know that I'm not redeploying everything. And I don't know whether that's actually an issue, redeploying everything, or whether it's just a mental kind of barrier, I guess, where it feels a big thing redeploying everything.
It is true that when you have a monolith and you deploy any piece of it, you have to deploy the whole thing. So, I mean, that is a trade-off, and there's pros and cons to that. Like when you deploy the monolith, you know that if you have a good CI/CD pipeline, you know that that thing that you just did in your module is being integrated with everything else, and all the tests are running for all of it, before it gets to production, assuming that you're running it through the CI pipeline first. Whereas it's much more difficult to guarantee that when you're a team that just runs the email sending microservice and you want to make a small update and you send it up. Like, it's quite unlikely that you have a bunch of integration tests in that case that make sure that you are going to operate with every live version of every microservice and application that's out there currently. Some teams do that, but it's more rare. And if you do that, then it adds a much bigger hurdle for you to go over every time you want to deploy. So it's all trade-offs, but I encourage teams to use feature toggles and to deploy as frequently as possible. So you should be deploying your modular monolith at least several times a week, if not daily. So then it's not a big deal to deploy. Like, we just deployed a couple hours ago. Everything looks good. We're going to deploy again now. Okay, everything still looks good. That's why you have a CI/CD pipeline, is to ensure that things are all working together, so that you have confidence when you deploy it that things will still work. And if they don't, because you just deployed and it worked a couple hours ago or yesterday, like, you only have a very small amount of things to look for where the problem is. Where teams get into trouble with these monoliths is when they don't deploy for weeks or months, and they finally do, and all heck breaks loose, and they're trying to figure out, well, what broke this? And they've got weeks worth of work from multiple developers to try and track down where the problem could be.
I can definitely echo that. I've seen that a few times, even with more microservice architectures, not just monoliths, where if for whatever reason some stuff hasn't been deployed for a while, then that's where the issues come when deploying to prod, where actually, and as you say, if you've only got almost one commit's worth of changes and it goes wrong, it's really obvious what broke that thing most of the time anyway.
Right. And if you need to roll back, it's usually pretty easy to roll back if it's just one commit.
Yeah, definitely. So I guess one thing I'm aware of with this, like if we've got one single code base and you've got it nicely separated out into modules, and then you've got different developers of different experience levels working on that code base, because I can picture it being quite easy for a developer to come in and just, without realizing it, add coupling where you wouldn't want it. Are there techniques to help prevent that?
Code reviews are always going to be your friend there, and pair programming can be a form of constant review. So, some level of discipline in the team to avoid mistakes or folks doing things that they shouldn't do or inadvertently do. In terms of the structure of the solution itself, there's not one way to do this. So I've got my approach that I share in the Dome Train course. And what I do is I leverage the project system in .NET heavily. And I make sure that the project references only allow the things that should talk to each other to do so. And what that means is that each one of the modules is a small collection of projects, right? Usually 3. And so there's a module project that is the thing. Like, let's say it's an email sending module, right? There's an email sender CS_proj file. That's the project that has the actual logic, right? But now other things need to be able to communicate that. Other modules would like to send email. How are they going to do that? Well, if they want to call a method that lives on a class inside the email sending project, the only way they can do that is to add a project reference to it. And if they do that, now, they're coupled to it, literally because of that project reference, but also that makes it so that there's no way for the email sending module to then depend back on one of them, because you can't have a circular reference in the project system. So to break that, what I've done is I've added a email sender.contracts project. And that is essentially the public interface for this module. And so it depends on the actual email sending module, and nothing else really does, with the exception of its tests. So that's the third project. So each module basically has 3 projects: the module itself, the contracts, and then the tests, the unit tests for the module. And so now anything else can depend on the contract of another module. right? And you'll never get a circular dependency that way. If you have modules A, B, and C, right, A can depend on B and C's contracts, and B and C can depend on, the other two's contracts, and that will never form a cycle. And so that's how you avoid the circular dependency problem, and that's how you enforce that the different modules only depend on each other through this public contracts project.
So does that allow you, I'm trying to think of example services, a user service and I don't know, an order service or something, but you've got two different modules and they need to talk to each other. Would you do it via these contracts?
Yes, and the contracts typically are using MediatR. So I'm defining commands and handlers and DTOs that are in those contracts. So, imagine that the contract is almost like your Swagger or Open API document for an API, right? It defines what the different types of messages are that you can use and what the return types are that you'll get. And then in my example, I'm making heavy use of MediatR, but there's other techniques that you could use if you didn't like MediatR for whatever reason. But if the order module wants to talk to the customer module and maybe get customer information, the customer module contracts project has a customer details query, let's say, and also a customer DTO. And so the order module can just tell MediatR, hey, I want to send a query with this information, customer ID 123, and go send that, right? And the handler for that lives in the customer module, right? So it will get that command, that query, and it will do whatever it needs to do to get the data. It'll make a call to its database and map it to whatever, and it'll send back a customer DTO. And now the order module has that customer DTO. And that's very similar to what you might expect to happen in a microservices application. But the difference is that in microservices, you would have had to have the order microservice make an HTTP or gRPC synchronous GET call to the customer microservice over the network, wait for that to come back, and then continue on. And that presupposes that other microservice is up and running and everything's working, right? And so your brittleness of your system goes up dramatically when you do that, because if your uptime for any given microservice is like 5 nines, well, if they need to talk to each other, those nines start dropping rapidly because they all have to be up at the same time. In the modular monolith, it's all in process, right? Even though I'm using MediatR, you can still step through it with a debugger. It's still happening in nanoseconds, not over the network hop time.
Yeah, that makes total sense. And did you just say that if people aren't a fan of MediatR, who's not a fan of MediatR? I don't know what you mean. There'll be half the listeners screaming right now and half not listening.
Yeah, there's folks out there that think MediatR's slow, and there's ways you can do it faster. You could probably use source generation and get a faster way to do it. And there's some argument that MediatR kind of gives you too much access to everything in the system, right? So it's hard to logically say, when I send some command to MediatR, where does that go? What are my dependencies, right? So there's a case to be made for MediatR being a little bit too broad of an implementation for what it does. But it is super convenient and makes structures like what I'm doing in this course really simple to do. So I'm still a fan.
Yeah, me too. I was saying that in jest, and I know some, as you say, there's a love-to-hate relationship with it, but I'm a big fan, to be honest.
I mean, it's not AutoMapper that most people hate, and even Jimmy hates AutoMapper, so, but MediatR still has a lot of love.
It's funny, I won't go into detail, but just yesterday in one of my clients' Teams channels, and there was conversations about AutoMapper, so it's quite coincidental, but I won't go into detail, but it's just quite funny. Speaking of MediatR, it's so if you're using MediatR, and MediatR's got this concept of sending out requests, so using commands and queries and things. It's also got a concept of notifications, which is you can almost, even though it's a function call, you can almost think about it as pub sub, yes. Which sometimes in my smaller projects, I use that for, almost to simulate messaging, even though it is. Mm-hmm. Conceptually, it feels like you can fire an event, something's happened, and you can have a few things like handlers or consumers, whatever you want.
Yep, it's great for that.
In a modular monolith, would you also reach, because obviously that is a function call, so you don't get the whole, if you're using a proper message broker, like Azure Service Bus or Rabbit or whatever you want to use, mm-hmm. where you get a bit more resiliency because things can go down and the messages stay in the message broker.
Right.
Would you still use a proper message broker when dealing with a modular monolith?
I don't think it's worth doing that personally, because the monolith, right? Imagine it wasn't modular and you weren't using message passing and you just had a module, right? And it made function calls and it goes down. Like that happens. Monoliths go down, right? And nobody is saying like, hey, every function call that you do inside your monolith should be going to persistent storage and mass transit and RabbitMQ, so that if by chance on this line of code the system craps out, that we will still have that message that ready to go when it comes back up. Like that's not a thing. So like, we already work with applications where at any moment on any line of code of execution, the system could crash. And MediatR is working at that level, right? It's just function calls. So, I don't feel the need when you're working in process with just pure function calls to try and persist all of that somewhere along the way on the off chance that the app might crash at that moment. It is a slight risk, but it's the same risk you have now in any of your applications that you're using method calls. So, we already accept that risk.
As you say, it's a trade-off. It's kind of, if you do go down that line, then there's a lot more complexity and it just takes more time. So it's kind of, is it worth all that time and complexity and ongoing maintenance versus just doing it like KISS, keep it simple? I don't like the actual KISS acronym. So I always say keep it super simple because that still stands for, that's still KISS, isn't it?
Right.
I think that's
or keep it
nice
simple,
word.
silly.
Exactly.
If you don't want to call people stupid, you can still use the acronym. Where I want to use messaging with durability is as soon as you have network calls involved, right? That as soon as you say I'm not communicating in process, I'm talking to a microservice or I'm talking to some other system, then that's where I think it makes sense to use mass transit or N-Service Bus, RabbitMQ, Azure Service Bus, whatever. Because at that point, you do have all of the distributed computing issues, and the likelihood that something will fall down in between the sender and the receiver is orders of magnitude greater.
I guess the scenarios I'm thinking about is kind of where an action requires something on the back end to do something that does heavy resource usage, maybe CPU or memory or something, where actually if you can just shove it on a message broker and let something else deal with it asynchronously, I think that's quite nice. But yeah, again, if you've got that case, it's kind of that particular case, split that off. But most of the stuff, just because you've got like one case that does that doesn't mean you've got to make the entire architecture a microservice kind of architecture.
That's right. And you can implement that without using messaging, right? So in my course, I've got an email sending module. And email sending is certainly something that doesn't need to happen while the HTTP request is waiting, right? That can be queued up and then sent. And so the email module happens to use MongoDB just to show that you don't have to use the same database for everything. And as soon as it gets a message to send an email, it has an outbox pattern that it uses. And it just writes a record to MongoDB. And then there's a background worker inside that module that is watching that table and just picks things up off the outbox and actually sends the message. But it's a separate process. Still part of the monolith, right? But not part of that request thread. So you do get that benefit of being able to send it separately, and you get that durability where, as long as the record was written to the outbox, if the whole system, dies at that moment, when it comes back up, it'll still watch the outbox, pick it up, and send the email.
That's a good point. With ASP.NET, you can have background workers, so it's not just about those requests coming in. You can add various things. And what's the cron job library that's quite popular?
Hangfire?
There's Hangfire and there's another one, isn't there? Quartz. Maybe I think it's Hangfire I'm thinking of, but you can use stuff like that. But it can all be together. Mm-hmm. So yeah. I did actually, when was it? It was a few days ago I listened to because you appeared on .NET Rocks talking about this same thing. And near the end, I can't remember who, I think it was Carl that brought it up, was that you've got a course upcoming, or it depends when, I don't know if it's out yet or not,
right,
about the reverse, going from microservices back to modular monoliths.
That's right. Yeah, that course got published the end of May, of 2024. So it's live now, and it's less technical. It's more for like a technical decision maker, not so much code, and more about these are all the things you need to consider, and how to pull things back from microservices into your monolith. And then a bunch of case studies to show you, like, you're not crazy. Other companies that you've heard of, like Amazon and Twilio, have published case studies about why they went from microservices back to monoliths in order to save money and improve performance and a host of other things. So, that's what that course is all about, is kind of giving you permission to reconsider the fact that everybody is saying microservices are the only way, and like, no, are they though?
I like that term, give you permission, because it is almost like you've done a lot of work to go to microservices, and I can picture people feeling that they're almost stuck because they've made that decision and commitment. And then it's interesting that you've done a course to go the other way, going back to a modular monolith. Is that again on Dome Train?
Yes. Yeah, that was my third modular monolith course. So the first two are about building modular monoliths for developers and maybe architects. And then the third one, like I said, it's for more like, technical decision makers and architects that are trying to plan how to fix the fact that they've gone too far down the microservice rabbit hole, and maybe they'd like to back out a little bit to something simpler and cheaper.
Oh, you're one course ahead of me on Dome Train then. I need to get another one out.
Yeah, I've got two more that are due like next month, so it's a race.
Oh, you're going to win that race. I've got like zero time at the moment, so I'm struggling. But yeah, it's quite interesting because I've had a few of the Dome Train authors on the podcast, and we always like get onto the topic of how you actually found actually creating the course. Because one thing I found a bit different with Dome Train is like Pluralsight, obviously the authors don't have the webcams on. And that's one big difference for me. Like with the Dome Train courses, the webcams are on.
Yep.
And as an author, that's quite a different experience. I've not done Pluralsight. I know you've got Pluralsight courses, haven't you?
Oh yeah, bunch of them.
How do you find the editing difference when you had to have your webcam on?
It was very different. I was happy with the fact that it was okay to have jump cuts inside the edits. If I had to do a perfect take of every clip, that would have been way more difficult. I definitely had to learn a new set of tools because everything I did with Pluralsight was always with Camtasia. And I think you can use Camtasia for something with live video, but I decided to just follow Nick's lead and use DaVinci Resolve, which is a much more capable, I think, editor tool for video, but also has a much steeper learning curve. So it took me a while to get the gist of that. But things like trying to make sure that I kind of look more or less the same, at least through a single module, even if I didn't record it all at the same time. Like those are challenges that you don't have with Pluralsight where you're just doing screencasting. But it does, I think, make for a little bit more of a better connection with the audience, with the student, where like they will get to feel more like they know you, like they've seen you, talking to them. They get that, Jonathan Stark calls that asymmetric intimacy, where, people will come up to you and say, oh yeah, I know you. I've listened to your podcast or I've seen your videos. And you're, as the author, you're like, you don't know them from Adam, but like, they have this feeling of knowing you because of that. And I think that's enhanced by having your face on the screen when you're talking to them.
Yeah, definitely. I think for me, you mentioned about jump cuts. Mm-hmm. Once I accepted the fact that jump cuts were okay, and as you say, it was really helpful that Nick kind of do jump cuts, it's fine. Because I think he was saying he'd much rather see jump cuts than uncomfortable pauses and waiting, thinking for the next thing to say. So once I embraced that, I found the quality of my videos improved a lot.
Right.
But yeah, when you were saying about making sure that your appearance doesn't change, that's like my first course I did last year, the Docker one, because it took me a lot longer to do because it was the first one. So that, as you say, like there's the learning curve of DaVinci Resolve and everything. Then I didn't think about things like even haircuts and stuff. So It's kind of like halfway through, I needed to get a haircut. So suddenly my hair has completely changed. Where in the second, I did the Kubernetes course this year, right before I started recording, I had a haircut, so I knew that I wouldn't have to have it at the end. And just things like that, which you just don't think about. But It's a huge learning curve, but great fun. So I'm so glad I did it because it's been such an amazing opportunity.
Yeah, it's been fun. It is a lot of work though, and I'm totally slammed right now. But I've got 2 courses I've got to get finished here soon, and then I don't know. I may take a little break from doing more courses because I'm way behind on a bunch of things.
Well, you've got your is it Nimble Pros, was it called?
That's right.
So you've got your consulting company as well. So yeah, time is a valuable asset, isn't it, really?
Yeah. And I've got some clients that would love more of my time, but I'm telling them right now I'm too busy. So I'm trying to work on these courses and get them done somewhere close to their deadline. So that's the challenge.
Yeah, I think saying no is quite a powerful skill, which a lot of people don't have. So I think it's very good for stress management, being able to say no to things so you don't get too many things up. Right, so was there anything else that like, as I say, I got halfway through your course, so there might be things that I've not thought of or to ask. Is there anything else that is worth mentioning around modular monoliths?
Well, there's a couple things that I could cover that are a little more on the technical side, if you like.
Yeah.
One of them, I've done some YouTube videos about this, and it's also covered in my course. But one of the benefits of using something like MediatR is that you can construct your own middleware pipelines inside your application. So, for example, if you have validation that you always want to do on messages coming into things, instead of having an order service class that takes in parameters, and then every single one of those methods needs to do validation on those parameters to make sure that they're in range or whatever. If you do embrace this message passing with MediatR style, you could send a query or a command to the order handler, and then you could have a fluent validation behavior or whatever type of validation you want to use. I use fluent validation, and every message will go through that behavior and will be validated. And if it's invalid, it'll jump back from that behavior before it even gets to the order service or handler that would ultimately execute it. Likewise, I have a behavior for logging, and so every single call gets logged, and so I don't have to go and add log statements to every method to say I'm starting and I'm finishing and I took this long or whatever. All of that is done by a single behavior that every single query or event or command goes through, and so in my logs I can see like this is exactly the path that this request took. From coming into an endpoint, and then from there going to, a query to a query handler, or a command to a command handler, et cetera. And so I'm a big fan of those behaviors for cross-cutting concerns, things like validation and logging, like I mentioned, but there's a bunch more if you think about it. You can use it for authentication and authorization. You can use it for caching and any number of other things you might come up with. Basically, if you're looking at your methods that are actually doing your business logic, and every one of them starts off with log that I'm starting this method, try, maybe do some validation or some guard clauses, do the actual work, and then have a catch clause, and then another log statement. Like if every one of them has that same shell of code around the real work, all that stuff can get pulled out into these behaviors and use what's called the chain of responsibility pattern, which is exactly what ASP.NET Core does with its middleware. So you're already using that pattern if you're doing ASP.NET Core. This gives you a way to use it inside your application logic so that it's not coupled to ASP.NET.
Yeah, definitely. With, as I say, we use MediatR quite a lot, and that scenario you just described with logs, we do the same with traces. So, like open telemetry traces, whereas so exactly the same concept you've just described, but for all our MediatR handlers, we don't have to make any changes there because we've got a behavior which just does that and starts and stops that trace, and we throw it into Grafana Cloud so we can see all the traces there. And if you were to do that manually for each of the MediatR handlers, you'd forget for a lot of them, but as you say, it's just we forget about it because it's just automatic. So yeah, very, very powerful.
Yeah. And then the other thing that is important with modular monoliths, I think, is this idea of having something bigger than a class as an encapsulation boundary, or even an aggregate, right? And so I talk about this a lot in my DDD courses and some of the workshops I do. But when you think about encapsulation boundaries in C# or in your software, right, it starts really at the lowest level, right, where you've got, a variable is kind of like an encapsulation boundary, an abstraction. And then you get up to like a method, and a method has, local variables that are only valid there, and that has value because you know that if you just create a local variable and you use it in that method, you're not going to step on anything else anywhere else in your program. And that's very valuable to know. And then from there, you can go up to a class, and at the class level, you can have private and protected and internal and other keywords to kind of restrict access to it. But beyond that, right, we don't have another level of granularity really inside of C#. And so the idea of using the modules as a way to achieve that by having that separate contracts project and making it so that, I didn't really mention this, but the main module, the email sender or the order service, whatever that is, everything in there should be pretty much internal. So that other things, even if they did make a project reference to it, they wouldn't be able to get to any of the things in there because they're all marked internal. And then you can use internals visible to, which is one of the tools that we have available to us, to make the internals visible to your test project. And if necessary, you can make them visible to your contracts project as well. Usually you don't need to because the way that the dependencies work. But by setting it up that way, you make it so that you do have still that encapsulation boundary at the module level, which is larger than just individual classes. And that's where you get this big ball of mud problem. It's because developers, even if they're great with object-oriented programming, the tools aren't there inside a single project to be able to encapsulate everything in this folder from everything in that folder. Right? We don't have anything that says, things in this folder, things in this namespace shouldn't be referenced by things in that namespace. Right? And so you have to use the project system to achieve that. Or you can also use something like ArcUnit, which is architectural unit test. That can do it as well, but then you don't get compile time support. You only get it when you run the tests.
Oh, you jumped ahead and pinched my dev tip. I don't know if I heard about this, but it's not the one you mentioned. There's something I saw recently by someone called Ben Morris called Net Arc Test, which is basically what you're describing, I think.
Yeah, there's two of them. That's the other one. Yep.
Looking at the README, it says inspired by ArcUnit library for Java. But yeah, for the listener's benefit, like just reading the description, a fluent API for .NET standard that can enforce architecture rules in unit tests. And just like looking at one of the examples. So if you picture and this is for the listeners because I know you know it, but if you picture like fluent assertions, that kind of fluent chained function kind of syntax, and just like reading the first example, it's that kind of thing where it's like types dot incurrent domain that resides in namespace, then it's got a string which is the namespace name, should not have dependency on then something else. And so it's doing an assert basically about your dependencies. And that feels, I guess, to go to my earlier question about for junior developers or people that were less experienced, and I think your answer was about having reviews and stuff. I guess if it's something like this is warranted, this is another way to actually enforce that by just having a set of tests that make sure that you don't break those boundary rules.
Yep, for sure. And as far as the code reviews go, like the things you would look for in a code review would be someone adding a project reference where they shouldn't, or making something public that was internal. Like, if you've got those guardrails in place, they're just code, right? And so someone that has full write access to the code can get rid of the guardrails. They could comment out that ARC unit or NetArc unit test too, right? So, you still have to look at the pull requests or the commits that are coming in, because someone can, thinking that they're doing the right thing, bypass some of those guardrails.
Yeah, that makes sense. So one final question before we wrap up. Where did the term modular monolith come from? Because I'm hearing it all over the show nowadays. And has it actually come from somewhere specific, or is it something that's...
I don't know who first coined the term. I know it's been around for a while. I've got a cartoon I post every now and then on my Twitter that's like, aliens coming down and telling people that they shouldn't just build microservices, they should start with a modular monolith. And, even when that cartoon came out, I think it was like in 2019 or 2020, it was a term that had been around for a while. So it's not really new, but it's becoming more popular, I think, because so many people have found themselves in the morass of microservice hell and are trying to find a way out that doesn't lead them back to the big ball of mud hell that they came from. And just to call back to that diagram that we kind of mentally talked about with the two axes, right? Toward the top was things that were modular. Toward the right was things that had many services. The problem a lot of companies come into is they try to go microservices, but they don't decouple them, right? So maybe they'll share a database. And so you end up in the bottom right of that quadrant where you've built a distributed ball of mud or a distributed monolith, which is the worst of all worlds, right? You got all the problems of a distributed system, and you're still in a tightly coupled big ball of mud problem inside of your architecture. So, definitely try and avoid ending up there.
I will include, if it's okay with you, that diagram in the show notes, just
Sure.
so the listeners have some context. And also that comic you mentioned about the aliens coming down.
Mm-hmm.
So I'll include those in the show notes. Cool. So we are almost running out of time, and I've already done my dev tip because it came up earlier. And I think you had a dev tip as well.
Sure. One of the tips I often share is that when you're doing maintenance programming, you should default to writing new code in a new class or in a new method rather than just going in and hacking some existing code or adding some code to an existing method. The reason why that is preferable is that, especially if you're building a new class, and this was great advice for when you're working on legacy systems that have huge, 1,000-line long methods and are just a mess, right? When you create that new class, you could write unit tests for it because it's brand new. You can design it to be unit testable. And you can construct it in whatever way makes sense to you. Name it the way you would name it, design it with all the best practices or patterns you want to use, and then just new it up and call it from whatever, giant method that you had before that you were trying to, insert some logic into. And if you do that long enough, eventually that giant method is going to be composed of, smaller classes that are unit testable that only do one thing, and the system will gradually get better over time. It also makes it much easier for you to use things like feature flags and stuff. If you've got, logic that is, logically separated into its own structure, into its own class or new method, than if it was just inline into an already too long method. So that's my tip, is if you're doing maintenance programming, try and default to writing new code in new classes instead of just editing and doing surgery on existing ugly code.
Yeah, that makes total sense. Awesome. So was there anything, before we wrap up, is there anything else you wanted to cover or mention? We've mentioned Nimble Pros. Any shouts out?
Yeah, the courses are live on Dome Train. I've got a whole sample there that I walk you through how to build. So I also have a template that you can use to create modules and create a modular monolith architecture, which is ardalis/modulith, like a modular monolith, modulith. And that'll be in the show notes too, I'm sure. So yeah, that's probably good.
Yeah, I'll definitely include links to all the different stuff in the show notes. Cool. So, well, with that, a massive thank you for joining us on the show. It's been amazing having you on.
Thanks. Glad to be here. See you next time.
And thank you everyone for listening. And a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, please do help me spread the word on social media. I normally use the hashtag unhandledexception, and I can be found on Twitter @Drakan, or X now, But the best place to get in touch with me is on Discord. And as I mentioned earlier, we've got our own Discord community, which is linked to on the website. And yeah, all the stuff, including that Discord link and the show notes, can be found on unhandledexceptionpodcast.com.